We've made it to the last free response question in this fake practice test for Chapter 1. The table below shows the poll ratings of a politician over time. Boo! Is the data best represented by a linear, quadratic, or cubic model? Explain your reasoning. Calculator. So what we're going to do is we're going to let our calculator literally do all the work for this. Okay, so probably for every single problem, for every single problem, we're going to go off to the side and let our calculator do the job. You might be thinking, well, in order to find out if it's linear, quadratic, or cubic, can't we do the thing where we see how much it goes up by and then do it again and then do it again? We can. But if these numbers are not exactly linear or exactly quadratic or exactly cubic, that won't work. So I'm going to let my calculator do all the work. So that's what we're going to do for part A. For part A, we're going to throw this into our calculator. We're going to see what kind of model it appears to be and explain why. So let's go off to the side and do that right now. All right. My job is to find out if all that information is going to be linear, quadratic, or cubic. So I'm going to go to Stat, I'm going to go to Edit, and I'm going to put in all that info. So the month is going to be all the stuff under L1, so that's just going to be 1 through 12. So type that out, or in this case, watch me type that out, like so. Make sure you make no typos. I think I can handle doing 1 through 12. Now for L sub 2, that's going to be the rating. So 1 matches up with 12, 2 with 18, 25, 32. If you don't want to listen to me say the numbers, you can just fast forward a little bit, or this would be a good time for you to drop a comment. Tell me how much you like my stuff. I see a lot of YouTube videos where people are like, make sure you drop a comment. So that's what I'm doing, and of course while doing this I'm getting very distracted. I can't multitask. What do we have? 35, 42, 49, 56. All right. Now again, my job is to use this information to see if it's linear, quadratic, or cubic. Okay, right now I just have a bunch of dots. If I were to hit graph, nothing. So what I need to do is while I'm in this section, not even while I'm in this section, we'll just make believe that never happened. Okay, this is what I have. In order for me to see the dots, I need to do a few things. I need to go to second y equals to take me to stat plot. Now what I just did is I put a bunch of stuff into stat, which means I gave my calculator 12 points. I'm going to want to hit enter to turn the stat plot on. And what it's going to do is it's going to show me the points. Now, there's an issue. My numbers were all double digits, so if I were to hit graph, I still won't see anything. So what I want to do is I want to see those stat points by going to zoom and going to 9 zoom stat. Now what we have here is a picture that goes up, comes back down, and goes up. Now this is not an exact science, okay, but this appears to be cubic. All right, I can draw a line, perfect no, but draw a curve rather that kind of creates a cubic function, okay, that looks like that. All right, so if we were to do the old-fashioned, let's go to the table and find out how much it goes up and then do it again, you're not going to be happy with the results. So by doing it this way, we were able to say, all right, even though it's not perfect, that definitely looks cubic because it follows the cubic pattern. So we were able to look at that information, and even though it wasn't perfect, it's definitely a cubic model because it follows a cubic pattern. Okay, so again, it's cubic because it follows like a pattern that looks like that. Okay, not exact, but close enough. Using your calculator or software, determine the equation for the regression curve that best models the data. Now that we know it's cubic, we can run off to our calculator, use the information that we already have plugged into this guy, and run cubic regression to give us a probably really gross but somewhat accurate equation. So let's go off to the side and do just that. Now, in order for me to find the equation of the regression curve, I already have my information plugged in. So I'm going to go to Calc here. I'm going to go to Stat first. Calc here. We determined that this was cubic, so I'm going to do cubic regression. Now, part C is going to ask us to use this equation for later use. So before I answer B, I'm going to do something that'll help me for part C. So I'm going to go down to Store Reg EQ. Okay, I'm going to save the answer that I get into my calculator so that when I do get to part C, life is a lot easier. So by doing Store Reg EQ, I go to vars, go to yvars, hit enter, enter, and this is now going to save my equation into the y sub 1 part of y equals here. So this will help me for part C. But part B is me going to calculate, hitting enter, and getting that god-awful mess. So we're going to write out y equals 0.161 x cubed minus 3.0130, because that's going to round up again, so that will be x squared, plus 19.849x minus 7.364. And so we'll go off to the side and write that out. So we ended up with y equals 0.161 x cubed minus 3.130x squared plus 19.849x minus 7.364. Use the regression equation to find the average rate of change in the politician's rating from May, which is month 5, to October, which is month 10. Explain what this rate of change means in the context of the data. So I was kind of wrong when I was like, oh, let's make sure we store this into our calculator. I was wrong, but I'm still going to go back and pretend like why that might be useful anyway. In this case, all we really have to do is use the information that we're given. Okay, if we're using the average rate of change, that's this formula right here, the same formula that you used a bunch of times, like so. Okay, U would be my A, and U would be my B, so 5 would be my A, and 10 would be my B, and then U would be my F of A, and U would be my F of B, right? So I'm going to run to my calculator, I'm going to figure out what 42 minus 41 over 10 minus 5 is, which I don't really need my calculator for, but I'm going to show you how to do that anyway because it's important to know what to do with fractions in your calculator. And I am going to demonstrate why maybe storing something like that into your graphing calculator might be useful for a different type of problem. Now to answer part C, what we're going to do is we're going to use that table. Okay, and even though I technically didn't need the equation, I thought maybe I would, I didn't need to. All that information is there stored for me. So if for some reason I asked you to do like the 14th month or something like that, what I could do is I can go to second table, scroll down to whatever I need, and do the 14th month or something like that. But I don't have to do that. I don't have to do that in this case, so I kind of jumped the gun, but I'm glad I did it because it showed you how to store those equations anyway. What I have to do here is use the average rate of change formula. So if I'm going from month 5 to month 10, I'm going to make sure I have 42 in one set of parentheses, 42 minus 41 in the other set of parentheses. Divide that by 10 minus 5. Now, I didn't need my calculator for this. I just wanted the excuse to show you that other thing. This is going to be 0.2, which is 1/5. So let's go back and change that. We're happy now. Thanks for watching. Finish the problem. All right, so we ended up with 0.2, which is also the same as 1/5. So what that means, explain what this rate of change means in the context of the data. That means that you only averaged 1/5 of a point in your rating in these 5 months. Okay, so this was only a 1/5 ratings increase over that interval. Not much, but that's what it means. So that's our last free response question. I hope this helps. I hope watching these videos helps you get ready for everything you might see in a Unit 1 test, whatever that might look like for you. But thank you very much for watching. I'm making Unit 2 and a Unit 3, so more to come, more to come. All right, thank you guys. Love you. Bye.